Hello, my name is Darren Thomas and I am the Director of Educational Research Techniques. In this video, we're going to be taking a look at the component form for vectors and how to use that information to find the magnitude and the direction of a vector. So let's go ahead and get started. Now, when we're talking about component form, essentially what we're doing is this. We have a vector called v, and the component form is where you take the information inside the actual the actual vector here. So this guy right here, v sub 1, v sub 2, these right here are our components. And so since this vector has, two dimensions, v sub 1 gives you our x direction and v sub 2 gives our y direction. That's kind of what's happening. Now, you can isolate v sub 1, v sub 2, etc. by themselves and treat them as if they're a vector. And so essentially what's happening is that, let's say if I take v sub 1, I would have a vector that is essentially, 2, 0, like that. Now, again, how did I get this answer? Well, we can solve it the long way. It might not be that beneficial for you, but we're going to do the intellectual exercise for that sake. Now, remember that, we're assuming that this vector is going to be in standard position. That means that our initial point is always going to be 0 sub 0, or excuse me, 0, 0. And in this particular situation, our terminal point, our TP, is going to be 2, 0. So now if I really want to solve for this, if I really want to do that, it will look something like this. So I would have, let's see here, I would have my x2, my terminal point, minus x2 minus x1, comma, y2 minus y1, like this. And so when you do all the math here, you can see I get the same answer I have above, which is 2, 0, 2, 0, like this. And of course, if I did this for the other one, of course I didn't give it a number because I didn't tell you the whole thing. Let's say v1 is 2 and v1 is 2 and v sub 2 is 3, like that. I would get the following answer for v sub 2. It would be 0, 3, like so. That's how it works. So I forgot to mention that v sub 1 was going to be 2 and v sub 2 is 3. And so I solved for v sub 1, but I forgot to tell you what it was first. Forgive me for that. And then for v sub 2 is 3. And so over here is the answer down here, but I didn't solve it this time. If I solved it, it would look like this. It would be 0 minus 0, comma, 3 minus 0, like that. And that's how I got my answer down here. So I hope that's clear. Just a little simple mistake on my part there. So if I were to graph this, it would look something like this. So v sub 1 we're always going to start at 0, and then we're going to go out here to 2. So that's kind of what that first vector is. This is v sub 1. Now v sub 2, which we just solved also, it also starts at 0, but then it goes up here to 3, like that. This is v sub 2. And when you combine these two, you get basically 2, 3. Again, this is our original one. And then you end up with this guy right here, and this is v. In other words, when we're talking about v, so v is when you have v sub 1 and v sub 2 inside a vector like that. And so this is v right here, this is v sub 1, v sub 2. When you combine them, you get v, the straight v. That's what's happening here. Now, let me give you another example here, using some different numbers so that we can kind of take a look at this. So now imagine that we're working with a vector that has the following. So I'm just going to call it v again for the sake of simplicity. And so v equals is going to be 4 and 6. So I don't have to do all those steps where I try to figure out the initial point and all those things. That's not that complicated. The next step we want to take is we want to find the magnitude. That's kind of the length of the line. And so to do that, you can basically just use the Pythagorean theorem. So if I were to continue with this idea, I would have the magnitude of v equals the magnitude of v sub 1 squared plus the magnitude of v sub 2 squared, like so. All right. Now this is not that complicated. So if we were to plug this in, so remember 4 is going to be our v sub 1, 6 is going to be our v sub 2. So if we want to solve this, it would basically be, you would have 4 squared plus 6 squared. And that's basically going to equal, again, you can solve this on your own time, it's going to equal the square root of 52. And 52. And if we simplify that as much as possible, we're going to get 2 times the square root of 13. That's it. Again, how to deal with radicals and things like that is, something we studied in prior videos. So this is the length of the line, if you will. So if I had to show you a picture of this is our vector right here. This length right here is going to be 2 times the square root of 13. That's what we have there. So, having said that, one more trick that we can do is we can find the actual direction, or you could say the angle of the actual line there of the actual vector. And so to do that is very, very simple. You take, you take tangent theta equals v sub 2 over v sub 1. That's our little equation here. And so for our situation, tangent of theta is going to equal, so this is going to equal 6, this is going to equal 4, like that. And so when you put that in your calculator, you're going to do, let's see here, tangent, you got to do use the inverse function, and so you get the theta equals the tangent inverse of 6 over 4, and that's going to equal about 56.3 degrees. That's what's happening there. And so again, you can plug this into a calculator yourself if you want to confirm this. Now, if I had to show you what this looks like, I could tell you right now that the measure of this angle right here is 56.3 degrees, roughly. And so by understanding component form, you were able to find the magnitude and also the direction of the line in terms of the angle of the line, in comparison to the axes here. So let me go back and try to summarize this and wrap up the video. So in this video, we looked at component form. And component form is basically looking at the individual pieces inside a vector and using this information for such thing as calculating the magnitude and or calculating the direction. And so essentially when you break it down into a component, you're looking at the individual pieces inside the vector, and you're almost treating them as their own vector, in that you take this original value here for x, it becomes its own vector with a terminal point of 2, 0 and initial point of 0, 0. That's standard position. And so you take that for each piece of information to calculate these things, and then you combine them all inside the actual vector that you're dealing with here. And so when you have this information, it can be very, very useful in terms of trying to find the magnitude and direction, as we already talked about it. And so one thing that I forgot to mention, just to make things nice and clear, is that when we talk about v equals 2, 3, let's see here, do I have any space? Okay, I got v equals 2, 3. So when I say v equals 2, 3, what I'm essentially saying is that, when I calculated that, I got it from this. V equals 2 plus 0, and then 3 plus 0, because remember, even the vector v is going to be from standard position. Now, going back here, you can see how we got that now, in that we are taking the individual pieces and then we are combining them to make the actual vector. That's what's happening. And so here's a picture of what was happening with that example here. So v sub 1 was 2, 0. It starts here. V sub 2 was 0, 3. That was it. And when you combine them, you get v, which is at 2, 3. So we go over 2 because that's for v sub 1, and then we go up 3 because that's for v sub 2. And this right here is our actual vector when the components are combined. That's what's happening there. And so then from there, we used a different set of numbers here to try to calculate what we call the magnitude, or in other words, the length of the vector. It's simply the Pythagorean theorem. So we took our two values here. V sub 1 was 4, and v sub 2 was 6. We squared them, and then we simplified them as much as possible, and we got the following answer. And then after you know that, or even before that, you can also calculate the direction here. And this is done by using the tangent function in terms of finding what theta is, and then using the inverse function, inverse of tangent, to find the actual degrees. And so again, this can all be done in your calculator, and you can see the answer right here. And when you take a look at the actual picture, You can see it's right here. So if I had to break this down for you, because we just did this, you know, V sub 1 would be 4, 0. So start here and stop right there. And then V sub 2 was 0, 6. So start here and go up all the way here. And when you combine the two, you get this black line right here that goes from 4, 4, 6. That's it. The length of this line is 2 times the square root of 13, and the direction is 56.3 degrees. And that is essentially some of the things you can do with component form. So I hope that this video made sense and you were able to follow what we talked about. My name is Darren Thomas. I am the Director of Educational Research Techniques. Take care.